students, today we are going to do the exercise 1.b of the chapter Rational and Irrational Numbers. Let's see the first part of this exercise. Here you have to state whether the following numbers are rational or not. For that you have to solve the squares over here. Let's see the first part of this one. We are having this in the first part, and now we have to use the algebraic identities which we have studied in 8th class, and here this is in a form of a plus b to the whole square. So this can be written as 2 to the whole square plus root 2 to the whole square plus 2 into 2 into root 2. Now solve it. 2 to the square, that is 4, plus this will be root 2 to the whole square, that will be 2 itself, and here 2 2s are 4, so 4 root 2. Now this can be added, so this will become 6 plus 4 root 2. Now as we know, the sum of rational number and irrational number is irrational number, therefore this will be a irrational number. So here we got irrational number. Now let's see one more part, that is the third part of this one. Here this part is in the form of a plus b and a minus b, so this can be written as a plus b to the whole square and a plus b, a minus b, so this can be written as a square minus b square, and in place of a we are having 5, so this will be 5 to the whole square and minus root 5 to the whole square. Now we see the 5 square will be 25 and root 5 square will be 5, and 25 minus 5 will be 20. So here comes a rational number, so this is a rational number. Now let's see the last part of this one. Here in this part we have to make the square of this one, so this can be written as root 7 to the whole square upon 6 to the whole square into root 2 to the whole square, and this will be equals to 7 upon 36 into 2, that is 7 upon 72. Now we can see that this is written in the form of p by q, so this one is again a rational number. Now in question number 2 we have to find the squares of the following numbers. So we have did the similar question in question number 1 also, so we will be doing only one part, and that too the last part of this one, and the rest you can try by own. Now here we are having the question, the fourth part of question number 2. It is again to find the square of this whole expression, and for doing so we are going to use the identity a plus b to the whole square, and this can be written as 3 square plus 2 root 5 to the whole square plus 2 into 3 into 2 root 5, and this will be equals to 9 plus 2 to the square 4 and root 5 to the square 5, 4 5s are 20, plus 2 3 are 6 and 6 2s are 12, 12 root 5, and this will be equals to 20 plus 9, 29, plus 12 root 5, and as we see this is a rational number, this one is irrational number, so the final will be a irrational number. After this, for the question number 5 and 6, in which we have to prove the root of 3 and 5 as an irrational number using contradiction method. I have already explained in one of the video to you. Now I have made separate video for those questions. Now we'll be directly move to question number 13, in which we have to arrange the given irrational numbers into ascending order. I am taking the second part of this one. Now we are going to write this and this number in a completely root form. For that, let's see. This is written as within a cube root of, if this 2 will be moved inside the root, you are going to write this one as 2 cube, because on making the grouping of 3 only, this 2 has moved out of this root. Now into 5, so this will become cube root of 8 into 5, and that is equals to 40. Cube root 40. And now let's see the other number, that is this one. This is 3 within a cube root 2. So this can be written as 3 cube into 2, and this 3 cube will be equals to 27 into 2, and that is equals to 54. Now from these two we can conclude that which one is greater. Therefore in ascending order, this will be written first, then this one. So we conclude that this is smaller than this one. Therefore 2 cube root of 5 is smaller than 3 the cube root of 2. Now let's see one more part of this one. Here in this question we are having 3 parts, that is 6 root 5, 7 root 3 and 8 root 2. So we are going to convert all of the 3 into the root form. 6 root 5 can be written as 6 square into 5, that is 36 into 5, and that is equals to root 180. Then here 7 square into 3 equals to 49 into 3, that is 147, and here 8 square into 2 equals to root 64 into 2 equals to root 128. Now we are having all of the numbers in a same root, so we can conclude which one is greater and which one is smaller. So therefore as this is the smallest, so this will be the smallest among these all. 8 root 2 smaller than this, that is 7 root 3, and then smaller than 6 root 5. This was for the ascending order. Let's see one question for the descending order too. Now here is the question in which again this and this both will be written in one form, and that is to the root of 4. So this will be 2 to the power 4 into 6. 2 to the power 4 means 16 into 6, and 16 into 6 will be 96. And now here again this will be done as the same which we have did for the in this one. So here 3 to the power 4 into 2, that is equals to 3 to the power 4 means 81 into 2, and this will be 1, 6 and 2. Now we can clearly see which one is greater and which one is smaller. So this is greater and this one is smaller. Therefore here 3, 4, 2 is greater than 2, 4. Then will we go through question number 15. Here in this question we have to compare the two given irrational numbers, and the beginning is same as we were doing in the previous questions. Now this can be written as 15 to the power 1 by 6 and 12 to the power 1 by 6. Now 1 by 4. Now we are going to take the LCM of 6 and 4, and that we get 12. So 15 to the power, in the base we are going to write 12. This means we are going to multiply this one by 2. So on solving this 2 we will be getting 1 by 6 again. Now over here this will be 12, and in the base we are writing 12. So in the top we will be writing 3, because 3 and 12 will be solved to get 1 by 4. Now here we can write this one as 15 to the power 2 whole to the power 1 by 12, and similarly here 12 cube whole to the power 1 by 12. Now they both are having the same power on the top. Now 15 to the power 2 will be 2, 2, 5 whole to the power 1 by 12, and this will be equals to 1728 to the power 1 by 12. Now we can clearly see which one is greater and which one is smaller. So here we got this one is greater. So root 12 4 is greater than 15 with 6. Here the question is to insert two irrational number between 5 and 6. For that, first of all, we are going to write this into the form of root. That is, 5 can be written as root 25 and 6 can be written as root 36. Now we can write any two number between these two roots. So required root 26 and root 27. Rather we can write any number from 26 to 35. Now let's see the next one. Here we are having to insert two irrational numbers between 2 root 5 and 3 root 3. For that, again we are going to do the same what we did over here. This will be written as 2 root 5 will be equals to 2 square into 5, that is 4 root 4 into 5, that is equals to root 20. Then 3 root 3 equals to 3 square into 3, that is root 9 into 3 equals to 18. Now we have to write the two irrational number between these two. Sorry, it was 27. Now the required two irrational number between these two can be anyone between 21 to 26 except to the 25. Here we have taken root 21 and root 22. We can take root 23, root 24, root 26, and that's all. We can't take root 25 because 25 is a perfect square of 5. And let's see the next question. Here we have to write two rational numbers between root 2 and root 3. So very first of all we see the square numbers between 2 and 3. The numbers which are the perfect squares between 2 and 3. So the perfect squares are क्या क्या हुआ? यहाँ रखा है. 2.25 comma 2.56 and 2.89. Now we can take the root of any one of it. So required two rational numbers are, so here we have got the required two rational numbers are root 2.25 and root 2.56. Let's see the question number 19 too. Here in question 19 we are having the similar question as of question number 18, and we have to find the three rational numbers between root 3 and root 5. So very first of all we will find the perfect squares between 3 and 5. Here we have got the perfect squares between 3 and 5. Now we can take any of the three for the required rational numbers for this question. So the required three numbers are root 3.2524, 3.61 and 2. That's all in this video. The last question you can do by own, and we'll be discussing the next exercise in the next video. Thank you.